Hello and welcome to another AdvancedSkeleton video. In this video, we are going to take another look at the face setup in AdvancedSkeleton. And for this, we will again be using the cool looking fairy character, which has been modeled by Patrick Evard. So in Maya here, we have the fairy. In this file, the body has been completely rigged and the face has been completely rigged. But what we'll do, as we're going to look at how to rig up the face, is the first thing we're going to do is to remove this face rig. And the way to remove a face rig from a AdvancedSkeleton character is to open AdvancedSkeleton. You go in the face section under build. You can first hit the button that says toggle fit advanced. That toggles over to the fit section of the face setup. And then that enables another button here called delete advanced. That will completely eliminate and delete the advanced face setup, leaving us only with the original fitting. Now, if you wanted to remove the fitting as well, that can be done by just selecting the object called face group and hit delete. So here we are. We got a rig that has a body rig completed. So let's go ahead and do this face setup from the beginning. We'll start with the pre-section. So the first thing that's got to be done is the pre-section's got to be completed by defining various objects. And the very first one is called mask. And if at any time you're unsure of what any of these selections should be, you can click on the little question mark button next to the original button. That should open a help image with some further explanation what to do. So we can see here for mask, the help image tells us to select poly faces that will be deformed by the face setup. So let's go ahead and do that. This is most easy to do from the side view. And we'll go over to face type selection and use the lasso selection tool. Now, as for how much of the face to include, I recommend imagining what part of the face will be deformed by the face setup. So we know we're going to have eyebrow controllers that's going to lift up the eyebrows, which is affecting the forehead. So we definitely want to include some of the forehead here. Likewise, we're going to go right back up until the ear as the jaw deforms up until there. And the jaw itself, as it opens, it affects down towards the neck. So we'll go down towards the neck a bit. And here we go. We got a selection. Now, just for the sake of keeping this tidy, I'll add these additional faces here to get more of a clean line where the boundaries are. Now, with these faces selected, we'll just go ahead and click the button that says mask. Now, it might take a few seconds to complete this operation, depending on the density of your model. One thing I do highly recommend is that before starting the face setup is to ensure that you are not using polysmoothing. Now, a quick way to do that is select the top node of your model and then you hit the one key on your keyboard to make sure nothing is polysmoothed. I know many times that users like to hit that tree button on the keyboard to make a more nice appearing smooth model, which can be great for many purposes, but in terms of the face rigging, it's gonna run the process much faster if you make sure select the model and hit 1 on the keyboard. Alright, before we move to the next one, I'll show you that each one of these buttons has a particular function that if you ever wonder what was the selection used for the original definition, is you can reselect. So if I was wondering what were the faces that were used for the mask, I can right click on the mask button and hit reselect. And we can see that these are the faces that were defined as mask. Next, it says, what is the face object? So that's going to be the main object that is the face. In this case, it's this object, which is the whole body. That's fine. So with that selected, we press the face button. Next, it says all head. And if you're not sure what it means, you can click on the help button. It'll tell you here that it needs a selection that it's all the objects that will be affected by the face setup. So we can see here that that would not just be this face object, but obviously also the eyes, the eyelashes, the eyebrows. Also, this headband here would be affected as the eyebrows get lifted. And the hair as well, particularly if we were to add a head squash to this face setup, we would also need to affect the hair. So with all that selected, I just quickly hit wireframe to make sure there's nothing left in here, and we can see that we did leave out the teeth and the tongue in this case. So I'll use the outliner to make sure I get the teeth and the tongue as well. And there we go. These, actually there is one more object in here that's not selected, and that's this tear line object. There we go. These are the objects that will be affected by the face setup. So with these selected, we'll hit the all head button. Next is the right eye, and this is a common place where it is easy to mistake the right and the left eye. It can easily be thought of that you look at the right side of the screen here and select this eye and define that as the right eye because it's on the right side of the screen. But that is not correct. It is this eye that's going to be the right eye. So it is the character's right eye. Again, if you're not sure, the help image here clearly identifies that it's the character's right eye that is meant to be chosen here. So with that object selected, we click right eye. Likewise, there's our left eye. All right, now we're moving on to optional additional surfaces. So not all characters will be using all of these optional definitions. So we'll just use the ones that apply. For now, I'll hide the face. I can easily see what's under here, and we can see that we do have upper teeth. So we'll choose that and hit upper teeth. We do have lower teeth. There's also a tongue. We also have separate eyebrow objects. So we'll define that. And we have eyelash objects. In this case, there's two objects. One which represents both upper lashes, another one that's both low lashes. So these two objects selected. And extras can be any kind of extra stuff. In the example image here, it shows that it's got beard, can be extra stuff. We do have an extra object here, which is this object, the tear line, which gives us that nice shiny glint just near the lower eyelash. So with that selected, we'll define that as an extra object. I'll go ahead and unhide the face. Next, we have a button called model check. Now this will have a look at the model and make sure it is firstly a clean model, meaning it doesn't have a variety of non-default transformation values. Like, for example, all the translations and rotations should be at 0. The scale should be at 1. The pivot points should be in the center of the world, and a variety of other things that should be default. Now this can be at times a bit hard to get right. This will look for any such issues. So we'll go ahead and run it. And in this case, there are no big warnings coming up. It just tells us the model is symmetrical. Now, just to show you what it would look like if you were having some issues, we can quickly introduce, for example, a problem. Let's move the pivot point of this model to no longer be in the center of the scene. If we now hit model check, you can see straight away we get an information box coming up here, and it tells us this object has these values for the rotate and scale pivots, which are non-default values and can cause issues. It is recommended to run the model cleaner tool before the rigging. So that's what that looks like. I'll go ahead and undo that to take it back to the original place. If your model is asymmetrical, it can either be a purposely designed issue to have a non-symmetrical face, in which case you can use the non-symmetrical face function to rig a non-symmetrical face. However, if it's non-symmetrical by accident, then I strongly recommend to resolve that issue to make the model symmetrical rather than proceeding with the non-symmetrical face setup, because that is going to take you longer. So you need to define a lot of points on both the right and left side. So if you're having any accidental non-symmetry on your model, you're more likely to get good results by fixing the model rather than rigging it as a non-symmetrical face. Okay, onwards. The next thing is to choose what rig type to use. We got 3 options here. Joint-based face setup, we got blend shape-based face setup, and we got mixed. And the default choice here is going to be joints, and that's also the recommended choice to be using. I would also here strongly recommend avoiding the temptation to just say, I want the best of everything, therefore I choose mixed. Because if you choose mixed, by the way, you can open the help image here to read more about this. And what I mentioned here about the mixed option, we can read at the bottom. The mixed option uses blend shapes as the base, but it also keeps on-face joints, allowing for additional control. Mixed provides the most flexibility and control, but here's the catch. If you are using mixed, you will get a significantly slower rig to work with. And it will also take you longer to get the rig right. You need to be working with both driving system and blend shapes and nested deformation. So unless you are 100% sure that this is what is required for your production, then I would not be using it. Next, we have some options. Let's quickly run through each one of them. First one, non-symmetrical. When you turn this on and off, you can see that the next section actually changes between just being fitting and be fitting for right. So with non-symmetrical on, you have fitting both for left and right side of the face. The non-symmetrical rigging option here is intended for those characters who are, by design, asymmetrical, such as the demo character Napoleon, which we can open here. This character is quite asymmetrical by design, so it requires the asymmetrical face setup. And if we toggle over to the fitting, you can see that most characters will have the fitting only on their right side, but this one has the fitting on the left and right side due to the asymmetrical option being used. Okay, next, game engine. As we can see, turning on and off, this checkbox is disabling certain sections of the options here. We can open a help image and it'll tell you here exactly what it's disabling and why, and it's got to do with compatibility. If you are to export your game engines, this is making sure you're not using functions such as nonlinear deformers and delta mush deformers, because those will not allow for export to game engines. Next, Apple AR Kit. Now this is for the functionalities that allows you to use iPhones to directly drive face expressions. For more information about this, I recommend to go to our YouTube channel and looking at the video called Demonstration 52 Face Tracking with AR Kit. Next is Advanced. Now this checkbox opens an additional section here, and the main purpose here is to allow for Advanced Skeleton face setup to be applied to rigs that are not Advanced Skeleton rigs, but any other kind of rig. If you are to do that, that is just fine. The only thing the Advanced Skeleton face setup is going to need to know is what is the head joint that is currently deforming the head. So you just need to select that joint and choose head joint. It will store that information here, and it will automatically detect the skin cluster used on the face and save that information here. So that is completing the pre-section. Next is the fit section. So there's a series of things that needs to be defined in here, such as where is the eyeball, where is the eyelid, so on and so forth. Now there's a few functions that all these buttons have in common. One is you click on the button to create the object. So eyeball, click on that, it will create the object. and the checkbox is turned on to show you that you have now completed this step. Now, other functionalities for each one of these is that you can turn off that checkbox to delete the fitting. And another option here is like, for example, the eyelid need to be defined by selecting edge loops. After they've been defined, if you're wondering which ones were the edge loops you used, you can right click and say reselect. That will give you back the selection that you originally used. So since we are next going to do the eyelid outer, we'll do that and then we'll show you how that button works. So if you're unsure what are the objects to be selecting here, there's the question mark button that will open up and show you a help image. So in this case, it shows you that the eyelid outer should be basically a edge loop running around the eyelid, which defines the boundary for where the eyelid deformation stops. You can double click on the edge to automatically select the complete edge loop. Now, depending on the topology, that might not always work. If that does not work, then you're free to manually one by one select the edges to ensure that you have a complete loop. So for now, we'll go ahead and use this. And there we go, we got our first edge loop definition saved. Now it's worth observing here that these are actually two objects, a green and a yellow one. So there's one for the upper part and another one for the lower part. Now a situation you can come across here is that you're unhappy with where the split between the upper and lower is happening. In this case, it seems to work quite fine, but let's say, for example, I wanted to move this split to become one or two vertices further down. One quick way to be doing this is that you can right click on the button, you say reselect those edges, you then click the checkbox, which will remove the fitting and leave you with the original selection. Now we'll make a change to the selection. So we'll go over to multi. That allows you to select multiple types of component, and we'll leave all the edge loops selected, but this time we'll select some additional vertices, and that will be the definition for the split between upper and lower. So for the case of demonstration, let's say we wanted the split to occur here on this side and here on the other side. Now we just hit the button again, and you see we get a custom defined split between upper and lower. Now that was just to show you. So what I'll do, I'll delete it and just go ahead and use the default split. So that's the eyelid outer. Next, we're going to do the eyelid main. The help image shows here that that's going to be the edge loop running on the most inner part, basically the part of the eyelid where the upper is going to be come in contact with the lower eyelid. So we'll use this edge loop for that. And then comes the eyelid inner, and the help image here shows us that this can be a bit complicated to select this edge loop because it's going to be right on the inside of the model. There is an assist button here, which we'll use. Hitting that is going to peel open the eyelid, which can look a bit bizarre, but it does help us to look inside under the eyelid and select the edge loop right on the inside. And then we'll define that as the eyelid inner. And at this point, we have defined all the three edge loops that composes of the eyelid. So it has created the eyelid object for us. Now, if you wanted to take a closer study of how that looks, you can go ahead and hide your model. And also we'll hit this button that hides the eyeball. And you can see how the eyelid fit object is looking like. How it starts on the outside, it wraps right around and ends up on the inside. I'll turn back on the model. The next three steps are very much like the eyelid steps, but this time for the lip. We see the help image here, giving us an idea what to be choosing. We'll start with the outer. Then we'll go to the main. And we'll use the assist function to peel open the mount, allowing us to more easily access the inside of the mount, and use this loop for the inner. And again, we'll turn off the visibility of the main object and just inspect that the lips are looking as expected, starting on the outside, wrapping right around and extending to the inside, and they're looking fine. Next are eyebrow locations, and as it says here, this time we're not going to select edge loop, we're going to select vertices. So the first one, select one vertex for the eyebrow inner. Now that's going to be around here, as we can see, matching the help image. Now, if you have the same situation as the fairy character here, you have separate objects that are the eyebrows. It is not recommended to be using these as the vertex position, but rather use vertices that are on the main mesh. I'll just pick walk up. That's going to give us that vertices that's right under that object there. There's going to be our eyebrow inner. Next, eyebrow outer, going to be the other end. So we'll select, I'll use the arrow keys to select one of the vertices right under that object there. Now the next one here is eyebrow center. Now I'll let you know that a very common mistake here is to go ahead and assume that what's meant is a center between the inner and the outer. That is not the case. So I've seen several users picking a vertices around this area and defining that as the eyebrow center. That's not correct. If you open the help image here, you see what's meant eyebrow center is the eyebrow center of the model. So what you want is to pick a vertex that's in the center of the model, but aligned with the eyebrows. So this would be the correct vertex. Now, they are the minimum number of controllers you get for the eyebrow. If you want several controllers for further details, you can open the optional extra eyebrow section here, and you can add as much as 3 additional eyebrow controllers. So for the sake of demonstration, let's just pick one more for this guy, maybe right here in the middle, and say that's going to be eyebrow mid 1. Next is probably the most trickiest of all these fit items, and that's because the selection needed for this is 3 vertices. This is going to be the forehead definition. Opening the help image here is show you that we're going to need to define these 3 points on the model, 2 on the center axis, and 1 on the side. So we'll leave the help image open. To access the one on the top here, I'm going to go ahead and hide both the hair and the headband. And firstly, I'll start with this one and the nose bridge. Now, ideally, that's going to be both in the center of the model, also aligned nicely between the split point between the upper and lower eyelid. So we're imagining a path running across here until the middle and on the nose bridge, and that's going to be a good vertex to choose. Next one's going to be on the top. One common mistake here is to not allow enough of this area to be deformed, because when the eyebrow later is moving, it's going to need to deform a certain area here. So I would not use a point here that is too low, as that does not allow for the area to define, but instead to go a bit further higher up on the head, allowing for a wider area to be deformed. Again, we'll trace a path running down from this until approximately we meet the point where that would also align up with where the lower eyelid meets the upper eyelid. So we imagine a line running out from here as well, and we end up with a point right about there. So we got these 3 points defined. Let's hit the forehead button. And here you can see we end up with a green object, and it is allowing for enough area of the forehead here for the eyebrow movement to deform this area. Next is a series of positions requiring 1 vertex selected to be defined. So jaw pivot. Now as the help image shows here, it's going to be kind of near the ear, where you can imagine a pivot point for the jaw bone when it opens. So for this character, I'm going to choose this vertex. Next, jaw corner. It's going to be near the jaw pivot, but it's going to drop down towards where a jawbone would curve off, start moving forward on the face. Next is called just jaw. Now this is kind of the tip of the chin, you could say, or tip of the jawbone. So we want this, first of all, to make sure it's on the center line of the model, but also from a side point, it would kind of run very low where the jaw corners are round towards the neck. So for this character, I'm going to choose this vertex. Next is called throat, and essentially, if you imagine the jaw opening, you can imagine that the previous position, jaw, is where the skin is going to fully follow the jaw, and then that weighting is going to fall off towards the neck, and throat is going to be the point where it has fully stopped being affected by the jaw. So we make sure it's on the center point, and we're going to go down a fair bit until, say, about this point. So this is where the deformation would stop when the jaw opens. It would be a smooth blend between the tip here, jaw, and the end here, the throat. Next, cheek. Now we're going to choose the cheek here. Now a common issue here is to go a bit too far out, say somewhere around here. I'm just going to turn on the soft selection just to indicate an area here. Now if you go too far out, that's not actually how most cheeks work. They are much closer to the mouth. Now the example image here might not actually show that very well. It might be better to do a Google image search on cheek. And we can see that the area that is often deforming the most is going to be quite close to the mouth. So for this character, I'm going to choose this vertex. Next is cheekbone. That's going to be a bit further up and essentially defines the area where the cheek controller stops having an effect. Next is cheek razor. Now this is going to be for a cheek razor controller that allows for a bit of additional squinting muscles that work under the eye. So for this character, I'm going to choose this vertex here. Next we have the smile bulge. Now again, we'll jump over and do an image search for a smile. And the smile bulge is essentially defining that this area that bulges out during a smile. Now that area that's going to start bulging out, I'm going to define as starting right here. Then similarly, we have frown bulge, which is going to align quite closely to the smile bulge, but on the lower side of the mouth. So we're going to have that bulging out be right about there. Next is the nose, which is right at the tip of the nose. Then nose under, that's defining where the nose ends. So from a side view, it's going to be right there where the nose meets the upper part of the lip. Then we got nose corner, which for this character, I'm going to define this vertex here. So far, so good. Now there are additional extra options here, and we'll take a look at what they are. So for the nose, if you do want to have some fine-tuning controls right on the nose, then you can go ahead and define these extra points, which is going to be nose side, nose center, and the nostril. Additional optional controllers, if you want to be able to control the tongue, which we do want here, we can define tongue. Now the way this works, it says no selection needed. So you just hit the button for tongue. You can see that that creates a series of locators here. And between those locators is a red line. So what we'll do is we'll go ahead and for now just hide the main face geometry. That allows us to more easily see the tongue. And then we grab all these tongue locators and make them more nicely run along the length of the tongue. So starting right back here. And I'll just use the arrow key to select between the different locators. Now, as a typical tongue has some more ability to deform near the tip, we will make these locators a bit more close together at the tip and then more further apart as it goes further back. And that'll do for the tongue. Turn back on the visibility of the face mesh. Next, optional pupil, and yep, we do wish to have controllers to contract and expand both the pupil and the iris. Note that in reality, the iris can contract and expand to reveal more or less of the pupil. So in here we do have the option to define the iris and thereby creating a controller that expands the actual iris. This is obviously anatomically impossible for all creatures that I know of, but we are often making cartoons and we want to have the ability to have that controller as well. So let's go ahead and define pupil and iris. Now all we need to do in this case, to make sure I select the right area, I'm going to turn on the hardware texturing. I'm going to go right to the edge that is around the pupil here and define this as the pupil edges. And next, the iris is kind of running halfway between these two edges, but I'll just go ahead and select one of them. I'll pick the other one and say that's our iris edge. Next is an option that says up, mid, low. Now if you open the help image, it actually, in this case, it shows you the effect that you get by adding this kind of controller. And it is a controller that allows you to distort the entire face, which is a bit of an unusual controller, as it is only used for very cartoony, extreme animation cases, as the real anatomy does not allow for this kind of deformation. But it can be useful, like it mentions in here, these controllers can also be useful to create various unique characteristics by creating variation characters based upon a single character. Now what we can do is jump over in another my session here again and have a look at Chubby, how those controllers work. So here we have the low phase, this is the up phase, and the mid phase. And you can see we get some comical and extreme different results by adjusting these controllers, although they are not something that anatomically is correct. They can still be funny controllers or useful for variation characters. Lastly, optional here is called Smile Line. Now this allows you to define the line that is the crease line that appears during smiling. Now for most characters, I would not recommend using this extra step. And let's open another character here to have a look why. So a character that is using this is Napoleon, which we can see here. If we toggle fit at once, you can see that it has those lines defined. Now having those do help around the bulging creases or bulges around this area here. But if you do use this function, you're also getting these extra controllers that by themselves might not be very intuitive to use. You can see here, if you move that smile line controller, you get a very unnatural behavior. So when the controllers move together, yes, you can get that kind of creasing, but the animator does get left with a larger number of controllers here that affect smaller areas. So it can be more non-intuitive to work with. For example, selecting the line controller itself is not something an animator could easily work with, as all these controllers would need to move together to form this kind of sharp crease. Now we open another demo character here. We can see that this character is not using a smile line definition, but we're still getting somewhat of a creasing effect when we're applying smile, just by the way that the formers and the joints are weighted. And obviously this is easier to manage from an animator's point of view, as we have less controllers in this area to work with. So for our character here, we will not be using a smile line. And that's it for the fit section. Next comes times to build. Now there are two main ways to build a face setup. One is the straightforward one called build advanced face, and the next is this other section called build followed by 3 periods. This is the step builder. It allows you to execute step by step the face setup instead of trying to execute the whole thing at once, since it can take some time. And the step builder is also have additional functions allowing you to improve on the result that you get for each step. So for our character here, we will be using the step builder option. Now, before even running the very first step here, I would recommend to test the deformation of the head. So you would at this point have a body rig of some sort, AdvancedSkeleton or other rig. So I would test that you can select the head controller and move, and the whole face moves with it. In this case, that's looking good. But to show what I mean, I'll jump over here and show you what would not be good. And that is, if you select the head controller and move, you would see the face being distorted. Now this is not a good starting point for the face setup. This can happen if you have used the AdvancedSkeleton skin cage function to be weighting the body. The skin cage weight body function works well for the body, but not so well for getting proper deformations between the face and the neck. If you had a case like this, you would need to go in and use the paint weight tools and make sure that the whole face and all parts of the face do move along when you're moving the head controller. So we're here making sure that the head controller moves all the face and all the parts of it. So we are ready to start the step builder. Let's go ahead. Starting step 1, prep. Now that completed without errors, and we can see that it has internally duplicated left and right. Face fitting. There are some advanced options you could look at here if you wanted to, and you can go in and see that as we have started the build process, we have a face build progress object, and within it there are various objects such as this cylinder here, which is the attachment orientation cylinder for face control. So you can see it's called face control orient. Now you can imagine that all the controls along the face is going to find its nearest point on this cylinder and use its orientations from that. So if you ever wanted to change the orientation of any of the controllers, you could go in and tweak the shape of the cylinder to have custom orientations. Next, control box. That has built the box, and you could already at this point, if you wanted to, change the position and scale if you wanted to. Next, eyeball. So that has built the eyeball, and you can test it by selecting the eye controllers over here. Moving this around should rotate the eyeball, and you'll also have the pupil and iris function already set up here. Next step is the eyelid. Now for each build step, you can see there are some subtext underneath that says what you can test along the way. So it says here, after running the eyelid step, that you can now test the fleshy eye. And that's done by selecting these controllers and moving them around. And we can see that we now get that effect where we called fleshy eye, where the eyelids are partially affected by the direction of the eyeballs. Next step, eye blink. And here we see the subtext says scrub the time slider to check with a little help image. Now, as the help image here explains, there has now been applied a 30 frame long test animation defining the behavior of this function. So let's do that. We scrub along, and you can see here that we're getting blinking of the eye, and we can affect the result of this by further reading in the help image. It says make sure you do any changes on frame 30. So if we go to frame 30, the last one in the animation here, if we wanted to make any changes, we can change what's being animated. And what's been animated here is the eyelid controllers has been changed, the value from blinks from 0 to 10. If for any reason we want to change that, say we could maybe want to overshoot that when the eyelids blink, change this number to 15. we can scrub and we can see the new result. So that's like way overlapping the two eye blinks now. So for our character here, the default value of the blink 10 is going to work well, but you might have another character where you might want to overshoot this to make sure the top eyelid meets the lower eyelid. So you can change the animation here. So by the time you run the next build step, this animation gets changed into becoming the nodes to build a rig. Next, eyebrow. And we can see that has built the controllers for the eyebrow. We can test that. We have the major controller, we have the minor controllers, and we have the driving system controllers over here. Next we'll run squint. Again, it says scrub the time slider to check. So you can see here what the result of the squint is. If we want to change it, you can just select this controller and see the animation, what's making the squint. For our character, I can see that it would probably make sense that this animated to move a bit further out and maybe even scale down a bit more. And again, move further out. And to test the result, we'll just scrub the time slider again and see this is now becoming our new squint behavior. So we'll keep that and run the next step, lip. That has created the lip controllers. If you wanted to, you can select, move them around and see the result. We'll go ahead and run the next one, lip fall off. Now here we have a few options to see the behavior. It's we can again scrub the time slider and see what happens as the part of the lip gets lifted up here. We see that we do this time have a more of a fall off, and we can adjust how much it falls off. So it has computed a few default values. For the outside, it's going to run along the surface for 4 vertices, and for the inside 2. Now let's change this to see the effect. So if we change that number to 2 and hit test, it's going to show you the selection of the new vertices. That's going to be the fall off area. So you can quickly see that if we change to a bigger number, 6, hit test, that's now the new fall off area. And if you wanted to use that larger area, you would just go ahead and hit update. Also, this works for the inside of the mount, and you might need to zoom in and take the camera on the inside if you wanted to change the fall off area for the inside. Next, we'll hit lip corner. And we can scrub the time slider and see how the lip corner is now deforming as we are changing the shape from a sharp shape to a rounded shape. Now, if you're not happy with this result, there is a number here you can change, and that essentially is how much to increase the smoothing of the weighting as you're moving from the center of the face towards the corner of the lip. For this character, the default value has worked out just fine. So we'll run the next step, smile pull. And as we see here, it says scrub the time slider to check. We scrub the time slider and we can see that the character's lips are being pulled up to form a smile. We can select the visible controllers here. These are the controllers that are affected in this motion. You can see the animation. If we wanted to change it, for example, we go to frame 30 and we move this controller, say we want it to even lift a bit higher. We wanted perhaps this to scale up a bit to create more of a puff and also a bit more cheek raising. So we have now changed that behavior, what that controller is going to be driving. Next, frown pull. And we scrub the time slider. We can see that here we don't get ideal results. However, we're just going to grab that controller here and pull it out a bit. Now, one actually common question at this point is how come I'm not able to select the controller right in the corner of the mouth itself here and move that? And that's because it has already been defined how to move when you smile and redefining how it moves when you frown. If those values were not the direct opposite of the smile, you would get very non-intuitive controllers. That is the controllers over here that allows you to go up and down to go between smile and frown. So if that were to radically change the direction that the corner was moving, you would get a non-intuitive results. That's why the corner itself is defined by the smile and therefore staying that way. But what you can change here is that area around that corner, how much that's going to react to the corner by bulging out. So we'll keep that as such. Next, narrow pull. So you can see how the mouth gonna look as the mouth is being narrowed. And you can see the animation here. If you wanted to, you can change the animation and thereby defining the behavior. Next is cheek. And we can scrub that and see how much that is being affected. It's the cheek control, essentially animated to scale up and move out. And that mouth corner control is moved a little bit too, just to give a natural kind of secondary reaction to the original cheek puffing out. Next, cheek razor. There's the cheek razor animation. Maybe we might want to change it just a little bit. I wanted to have it even more exaggerated. Maybe it scales up a little bit. Next is jaw weighting. And if we scrub the time slider here, we can see that's the jaw opening. Now there's a couple of unique options you can tweak here. You can tweak the weighting by tweaking curves. So you see we ended up with a couple of curves here that is defining the boundaries for the deformations. Now this bottom curve here in particular did end up snapping to the wrong point, so we're going to improve on that. We're going to move these guys a bit, just to more closely have these skinning boundary curves running more close to the geometry. Also the green curve here, we're going to straighten out a bit more to have it run more straight. So how these curves relates to the weighting is that you imagine the blue curves is where the weighting is completely no longer affected. The green curve is where the weighting is fully weighted to the jaw joint. Now this red curve is going to align with the lip corner and be the 50% weighting curve. So now that we have tweaked this to look a bit more clean and match, lining up with the model, we'll just go ahead and hit update. And now when we scrub the timeline, we can see that we are getting a better, cleaner jaw weighting results. Next step is jaw open. Now the jaw weighting was done in the previous step, but this step is looking at the secondary motion. So we scrub the timeline here. We can see that it has now also incorporated the cheek to be sucked in ever so slightly as the jaw opens, to give the reduction of the volume that naturally will happen when a jaw opens. It also moves two of the lip controllers to get a bit of a nicer rounded lip corner automatically as well as part of the jaw open. And again, any changes you tweak it to improve on the look, make sure to go to frame 30 to make that change. If you are accidentally here at any other frame and making that change, that's going to give you a strange animation where it moves out before coming to the complete end, and also the animation gets completely ignored when it bakes the animation into the nodes when running the next step. So it's important to remember any changes should be done at frame 30. So let's say we're happy with that result and go ahead to the next step, nose. We see we get nose controllers here. Next, snarl. If you scrub this, you can see that this is where the character does a snarling motion. This is going to be the effect you get when moving these controllers up, which is why these are showing at this point. If you wanted to change it, you can do so by moving the controllers. Again, make sure you're on frame 30. If you wanted to exaggerate the effect, having these guys move even more, you can even mix in scale and rotation at this point if you want. Test your results, scrubbing the time slider. Okay, that's what we want to keep it. Let's run the next step. Tongue. That's automatically hidden the main geometry for us, just showing the tongue and its controllers, so we can very quickly just test that yes, it's giving us the controllers and the deformation is looking all right. Next, regions. Now, regions are the broader region controllers that allows you to move like the entire lip and the entire nose. Also note that region controllers by default are not showing, just to have a less dense controller showing. So The control box here has a bunch of attributes of what type of controllers are showing, and these green region controllers are going to be by default off. Next step, IAim creates this look at controller, so it's going to look at this target. Next step, up, mid, low. Now that's essentially just not doing anything because we did not define a up, mid, low in the fit section. Next, phonemes, which creates the phoneme controller. Now we're not going to make any changes to these results at this point. If you ever wanted to improve on the results of each of the phonemes, that's something that you can do after the build is complete in the driving systems section. Next, emotions. That's giving some of the basic emotions here. We got happy, angry, sad, surprise, fear, disgust, and contempt. Again, if you wanted to tweak this later, you can do so in the driving system section. And we'll run the last step, finish. And there we go. We got a complete face setup. And a quick way to do a quick test is just open a selector, or you can go into the mocap library. In here, there's a subsection for face, and you can import face test animation. And we'll just play that animation. So there's plenty of room for tweaking and improvements, but it is a starting point for now. Now for tweaking and improvement, what you might be working most on is the driving system, so which essentially is defining the behavior you get as you adjusting these control box controllers. For example, if you want to adjust the behavior you get when you move this controller straight down, is you move it straight down and go to the driving systems section, which is under the pose section, and hit edit. We can see that that is now again created a 30 frame animation of the animation you get driven by that controller. If you wanted to change how it looks, you just apply those changes here at frame 30. Maybe we wanted it to move even further down. If we're happy with that, we hit apply. And that's how we have redefined the behavior you get when moving this controller down. Likewise, you can edit the result you get by moving it in any direction and combination of directions. Also, the custom attributes such as squints can be edited. And furthermore, you might want to adjust the weighting, which you can do by just selecting the objects and go to the paint weight tools. You'll see that it has here a long list of all the face joints. Quick way to getting to specific face joint is, for example, if you wanted to paint weight for the cheek controller, you can just select the controller and in the face section under tweaks. If you here use the paint skin weight tool function, it will open the skin weight tools. It will also automatically select the corresponding joint for that controller. So you get ready to go ahead and start painting. Another very useful function is delta mush. If you are not doing game engines. If you're doing game engine export, this function is going to be disabled. But if you're using Maya, this function is possible to use, and you can quickly get some improved deformers by doing that. So just quickly, let's select the main mesh and create delta mush. You see we get the delta mush deformer, and moving controllers now, you can see we get much smoother deformations as delta mush is a relaxer. One thing to keep in mind if you're using this is that when you apply a blink, the eyelids is no longer fully blinking. That's because relaxation has been applied to the eyelid, and you can see that by dialing the envelope in and out. When setting the envelope to 0, you see the original had the eyelids fully closing, but envelope back to 1, you can see that they no longer fully close. A quick fix for that is select eyelid area and then hit 0 weight selected. This will make sure the delta mush deformer is weighted to 0 for the eyelid. Also useful for the lip. So select lip area and 0 weight that, so that delta mush deformer is not destroying the ability to get precise deformations on Then you can also quickly add your own custom controllers with this section here called custom controllers. The way it works is you create a soft mod anywhere on the face. For example, if you wanted a controller here to move this part of the face for any reason, you just create this soft mod and hit the button, create a skin control. Give it a name. Call this cheek 2 since there's already a cheek controller. And we now have new controller both left and right side that deforms this area. And there we go. Face setup in AdvancedSkeleton. That's it for this video. I hope you have enjoyed it, and I'll see you next time.